Hey, in this video, we are going to look at gas stoichiometry, pages 13 and 14 of homework packet 8 on gases. I am going to screen share here, I think. Okay, and let's see if I can find that. Here we go. All right, I'm going to grab my marker here. And this is a adjusted mole train. And I've extended it to include liters. So we have the usual moles to grams or grams to moles to atoms or molecules to moles to liters for solutions. We haven't done that yet, and we won't do that now. And moles to liters for gases. Well, 1 mole is 22.4 liters at STP. So if I take my moles times 22.4, I get to liters. If I'm given a certain number of liters, I divide by 22.4, I get to moles. So that is just an extension of a mole train we're going to look at. And I'm going to do number 3 on page 13, I believe. And the question asks, what volume of hydrogen gas forms when 6 moles of hydrochloric acid completely reacts with excess magnesium at STP? So the trick here is I can't just take 6 times 22.4, because that's how we convert moles to liters, because I got to be converting the right substance to the right substance. So we really have to use an extended mole train in this process. And I'll just demonstrate that with the stoichiometry below. So I have 6 moles of HCl. All right, and I'm trying to find the volume of H2 gas that is produced. Can I compare a reactant and a product? Yes. So the first step is to take my moles of HCl and then say for every 2 moles of HCl, I only have 1 mole of H2. So I got to take 6 times 1 over 2, or 6 divided by 2, to realize that my 6 moles of HCl is really going to be just 3 moles of H2. All right, once I have my 3 moles of H2, what I'm going to do is say, oh, well, if I know moles of H2 and I'm trying to find liters of H2, I just have to multiply this by 22.4. So I take that 6 divided by 2, which is 3, multiplied by 22.4, and that gives me 67.2 liters. Now, what happens if you are not at standard temperature pressure, which is 273 degrees Kelvin or 0 degrees Celsius, and then 1 atmosphere pressure? Can you still solve these problems? The mole train doesn't say you can, but if you said you're at PV equals nRT, you can end up solving this. And here's how we're going to do it. All right, so I'm going to just take a look at this problem right here. And it is the same problem with the same balance equation. I have 6 moles of hydrochloric acid, but this time, and I'm asked for the volume of hydrogen gas, but this time we're at a lower pressure and at a much higher temperature, 95 degrees Celsius. So can I figure that out? Yes, I can use PV equals nRT, and I put my pressure at 0.9 atmospheres. I don't know my volume. Now here's, I gotta be careful. I'm talking about the number of moles, not of hydrochloric acid, but of hydrogen. So I take the 6 times 1/2, and that gives me 3 moles of hydrogen. Very much like this first step here. I'm using the gas law constant 0.0821 because I had the 0.9 atmospheres here. And then I got the 368 Kelvin. So I took 95, added 273. I have 368 Kelvin. Okay, notice I have these numbers over here. The units match up, the Ks do. It looks like I got liters, so I'm going to get an answer in liters. I punch in 3 times 0.081 times 368 divided by 0.9, and I get 101 liters of H2. Okay, I'm just going to do a comparison here. Why am I getting a bigger volume? Well, I raise the temperature, so molecules will move faster, strike the sides of the container and push that out more. And plus, I'm at a little bit lower pressure than standard pressure, which also causes the volume to expand. So those 2 factors should give me a bigger volume. And that's what I was able to figure out here. So yeah, you're using your extended mole train with the 22.4 liters per mole at STP, but you could always use PV equals nRT if you know the temperature and pressure to connect the number of moles to volume right there. Thank you for watching. Try page 13 and 14. Thank you.